You're going to find theta and the 5 trig functions in quadrant 3. The key is that this is in quadrant 3. Given that cosine of theta is negative root 3 over 2. Well, I can ignore the negative and just draw some right triangle. Cosine is opposite over hypotenuse, no, adjacent over hypotenuse. So this is going to be root 3, and this is 2. And if I do Pythag, it's 4 squared. It's 4 minus 3, which is 1, so that's 1. So now I can find sine, cosine, tangent, cosecant, secant, cotangent. Sine of theta is going to be opposite over hypotenuse, or 1/2. Cosine of theta we already have. Tangent is opposite over adjacent, or 1 over root 3, or root 3 over 3. Cosecant is 2. Secant is negative 2 root 3 over 3. And cotangent is root 3. Now, all of these sines and cosine values are actually going to be negative. Why are they all going to be negative? In the third quadrant. And in the third quadrant, both x and y are negative. Okay, so the cosines and the sines are negative. Here, in the first quadrant, cosine's positive and sine's positive. In the second quadrant, cosine's negative and sine's positive. In the third quadrant, cosine's negative and sine's negative. In the fourth quadrant, cosine's positive and sine's negative. So quadrant 3 is telling us which of these are negatives and positives. Tangents are positive because tangent is sine over cosine, right up here, sine over cosine. So a negative divided by a negative is going to be a positive. What's theta? Let's define theta also. The reference angle might be 30, but it's not 30.
It's 210.
It's 210. Why is it 210?
Because I just looked on my unit circle and that's where the 210 is.
Sure, this is a unit circle ratio. You can find that on your unit circle. Negative root 3 over 2 happens at 150 and at 210. At those two places. That's where the cosine of theta is negative root 3 over 2. Since we're in quadrant 3, we know it's this one. So theta equals 210 degrees. Another way we could have found that is by doing the inverse cosine of negative root 3 over 2. Negative root 3 over 2, that gives me 150. Well, that 150 is in quadrant 2. I need to put it into quadrant 3. Let's do 2. Questions on number 1? Okay, we talked about graphing sine functions yesterday. Did anybody watch the video I put online about graphing sine functions? Awesome. Yeah. So glad I did that. What a great use of my time.
I'll go home and watch it tonight.
Whatever. The period of a sine function is usually 360. Sine and cosine have a period of 360. But if there's a b value, you divide that by the b value, and now my period is 120. So I'm going to go out, so I'm going to add 4 hashes, just that's what I'm counting by. So 1, 2, 3, 4. And this 4th hash is going to be 120. Green team back here.
That's why I was trying.
I'm so scared of being so dumb.
Okay, so to recap, starting at 0, gentlemen, I go 1, 2, 3, 4 hashes, and the 4th hash is my period, 120. So this would be half of that, 60. This would be half of that, 30. And now I'm really counting by 30, 0, 30, 60, 90, 120. If I wanted to, I could keep going 150, 180. The amplitude is the number in front. So sine sine starts in the middle, because the sine of 0 is 0, but now it's going to go as high as 5 and as low as -5. And sine's going to go middle, high, middle, low, middle, high, middle. And I kind of draw these little lines where these dots look. The curve goes like this. In the direction, I can go low, middle, high, middle, low, middle. Will you all please stop talking in the back? Thank you. Oh. I never checked off your 5 homework, did I? I was just not, anyways. Okay. Is there a question about that? Yeah.
Hey, yesterday, didn't you say something about, like, finding, like, you know that it's 30, 60, 90, and then going to those and finding the sign and then plugging it in?
Yeah, and you can do it that way, but if you understand what's going to happen with those values anyways, you can just follow that method I just gave. Yeah, so you can plug in values if worse comes to worse, but you don't really need to. Other questions? Okay, let's do it again, but in radians. So same exact function, but now we're going to do it in radians. Usually, what's the period of a sine function? Nothing's been changed. What's the period? 360. Good. What's that in radians?
2 pi.
So usually the period is 2 pi. But now we're going to divide it by this 3. So it's actually 2 pi over 3. My amplitude is still 5. So when I graph this, and I go 0, and then I do 4 hashes, this isn't going to be 360 or 120 or anything. This is now 2 pi over 3. That's one whole period, one whole cycle will happen at 2 pi over 3 radians. So then what's this one going to be? What's half of that?
Pi over 3.
Pi over 3. Take 2 pi over 3 and divide it by 2. Well, 2 pi over 3 divided by 2 is really going to be 2 pi over 3 times 1/2. The 2's cancel, and it's just pi over 3. So this is pi over 3. What's this one going to be?
Pi over 6.
Pi over 6. So I'm actually counting by pi over 6's. It goes 0, 1 pi over 6, 2 pi over 6, 3 pi over 6 is just pi over 2, 4 pi over 6, 5 pi over 6, and 6 pi over 6. 6 pi over 6 is 1. I could go backwards if I wanted to as well. Then I'm going to go up to 5 and down to -5, and then it goes middle, high, middle, low, middle, high, middle. And backwards. Do. Same graph, just in radians. The hard part about radians is you're doing with fractions instead of with those nice pretty 30s and 60s and stuff. But that's okay. Question there? Okay. Over on the right, I've got a unit circle. And over on the left, I have a graph of sine of theta. And we're going to kind of think about what happens as these graphs kind of move together. So if I fill in this unit circle real quick, this is the point 1, 0. This is root 3 over 2 and 1/2. This is root 2 over 2 twice. And this is 1/2 of root 3 over 2. And this is 0, 1. I'm going to draw one of our terminal angles, like so. Think about sine. Sine means the y value. So over here, we're really graphing the y value as theta increases, as the angle of theta increases. As the angle of theta increases, the y value gets higher and higher and higher and higher. And over here, the y value starts going higher and higher and higher and higher as theta increases. Once theta gets to 90, the y value is at its highest point. It doesn't go above 1, just like how here at 90, the y value is at its highest point. Then theta is still increasing, the angle is still increasing, but now the y value is going down. And the y value keeps going down until you get to 270. And that's what's happening here. The y value keeps going down until you get to 270. And then it starts going back up, and it's just going to keep going up and down and up and down and up and down and up and down as theta increases. As theta increases, the angle keeps spinning, and so the graph keeps going up and down. That's why you have that repeating function, or why that's why it's called a circular function. Because it repeats and because it comes from this graph here. One of the places where this is really useful, anything that has a circular action is going to be modeled with sine or with cosine. And like lots of robots or robotic things or machines, like your car. Your car's got a bunch of pistons that look like this. And there's little tiny explosions with gas that push those pistons up and down. And as those pistons move up and down, they're attached to a crank. And that crank is attached to something in your engine that eventually goes to your transmission. And as this thing goes up and down and up and down, the crank goes up and down and up and down, and that spins your transmission and spins your wheels. That's how your car goes. But we can use a sine function to model the up and down action of that crank. And once we have a function, an equation, we can start calculating things like power or acceleration or where you have the strongest points and the weakest points. And all like the maximizing and minimizing of the car's fuel efficiency and power and all those things that they play with are ultimately coming from sine and cosine functions. So you can model the repeating action of something going up and down or something going in a circle. Whenever you have a wave like this, it's called a sinusoidal. Yeah, sinusoidal graph or function or whatever. Meaning it comes from a sine. Yeah, it's a funny word. Sinusoidal. So anyways, that's how these graphs come about, and that's what they're used for. One of them at least. Today we're going to talk about tangent. But I'm going to use the same unit circle and kind of explain, or kind of look at it first. So this first example won't be how to graph it. We'll do that on the next slide. This first should be sort of like what happens with tangents. Remember that tangent is sine over cosine. We've talked about why that is a lot. What's the tangent of 0? The tangent of 0 would be this point here. Sine over cosine is 0 over 1, which is 0. The tangent of 0 is 0. Then we'll go halfway. What's the tangent of 45? 1. Root 2 over 2 over root 2 over 2. It's something divided by itself. So the tangent of 45 is 1. How about the tangent of 90? That one's undefined. That's 1 divided by 0. It's undefined. Whenever you have something undefined, that's where we see asymptotes in graphs. So tangent has an asymptote at 90. Actually, I'm going to erase all that in.
What about negative 90?
What about negative 90? It's a great question.
1.
Well, this is the point 0, negative 1, still undefined. So actually, if I go to 90 and negative 90, or same as 270, I have an asymptote here and an asymptote here.
What about after them?
We'll get there. If this is 90, what was this?
45.
And what was the tangent of 45? We're going to call this 1. What was the tangent of 0?
0.
What's the tangent of negative 45 going to be? Since this is negative, but this is positive, it's going to be -1. Okay, the tangents here and here are negative. But in the quadrants 1 and 3, they're positive. So it's -1. The graph of tangent actually goes like this. Yeah.
Is there like a, what's it called?
Tangent. Yeah.
Oh, there's a name for it.
Yeah, not one that we've encountered before.
How come tangent is
And
also
also-
the term for like a straight line?
I love that question. I will answer that when the chapter's over. I've got a big day planned of answering questions kind of like that.
Okay, isn't that what a graph looks like if it's like it's cubed?
Yes, that's how a cubic
That's what I
function
was.
looks.
Okay,
Got it.
that's
Mhm.
what it is.
Yeah.
That's kind of smart of you.
Yeah.
Wow.
That was nice, Emily.
Oh, Mr. Baumgartner.
Um,
Oh, Mr. Baumgartner.
I had Mr. Baumgartner.
Yeah.
Let's talk about the tangent of 89 degrees. In fact, let's do like 89.9 degrees. As close to 90 as we can. What is the sine value if I'm at 89.9 degrees?
It's like 0.9.
It's really, really, really close to 1. It's like 0.9999999. It's really, really close to 1. What's the cosine value, the x value? Really, really close to 0.
So that's
Whatever.
why it's up.
So it's going really, really big. 0.999 divided by 0.0001 is like 10,000 basically.
Oh, wow.
So tangent can go up forever. It goes to infinity because you can keep getting as high as you want because I can keep making this angle as close to 90 as I want without actually hitting 90. So it's going to go up forever over here, and it's going to go down forever over here, which is why we have this negative piece happening down here. Now with tangents, this can keep happening over and over. Here's another asymptote. And I'm going to have 0, 0. That's going to be at 1. That's going to be at -1.
That's all that happens.
I'm going to have an asymptote here.
What, it's never like, run into each other?
Nope. Because of the asymptotes, they're separated from each other.
Wow.
I get these graphs over and over. Just going to repeat like that whenever you want it to. If we do it on our graphing calculators, I do y equals the tangent of x, and right now I'm going to put this in degrees. I'm in degrees. Well, I'm going to change my window so the window of my calculator looks like the window of my graph. Right now my graph is going from, this is 90, so 0, 45, 90. This is 180, so this is 270. So this is -270. My graph is going from -270 to 270. And I'm basically counting by 45, so that's what that scale means. I'm counting by 45s.
What's the period?
Right now it's 180.
Why?
Again, let me get there, okay? I love your questions, but I've got that coming. We'll go from -10 to 10, and there's the graph. It's kind of stressful when you see it.
Yeah, looks
Like-
like a heartbeat.
It is what a heart, yeah, I mean, again, repeating function, a heart repeats over and over, you get sines and cosines and tangents.
That's crazy.
Mm-hmm,
I know it's repeat.
yeah, very true.
I'm confused, alright? So, with the heartbeat, so there's a small fraction of a second where your heart just doesn't work.
No, it's just modeling the heart, it's not actually doing the heart. But there is a period of time where your heart's not pumping, because it's in between pumps. Right? When you're between pumps, it stops pumping for a fraction of time, if you want to think of it that way. Yeah.
You're dead.
No, because your blood's still moving. Your heart's not pumping, blood's still moving. Okay. So here's what I'll kind of break down how to graph these now. Kind of go step by step. The period of a tangent function is not 360, it's 180.
Always 180?
180. Well, it'll change with these b values, but the base period is 180.
Okay.
So to calculate periods, we do 180 over b instead of 360 over b. So in the case of this graph here, this tangent of 2 theta, the period
180.
is 90. 180 over 2, which is 90, because this is my b value. Now here's where tangent is different than sine and cosine. With sine and cosine, I would start at 0, and I'd go out 1, 2, 3, 4. With tangent, instead of starting at 0, everything's going to be centered at 0, and I'll go 2 to the right and 2 to the left. Everything is centered around 0. If the period is 90, that means that this total distance here is 90. That means that this is 45, and this is negative 45. So that's going to make this 22 and a half, and this negative 22 and a half. And that's, of course, 0.
You start at 0, 0.
Well, what's the tangent of 0? It takes some thinking, I know, but if it's sine over cosine, that's 1 over 0. Tangent of 0 is 0. Yeah, so I have the point 0, 0. What if I plug in 22.5 for theta, Max? What's 22.5 times 2?
45.
Good, what's the tangent of 45?
1.
1. So that's what's nice, is this is up at 1, and this is going to be down here at negative 1.
That's 22.5.
Yes. Because 22.5 times 2
Oh.
gives you your 45. I have asymptotes at the negative 45s and the positive 45s. My graph's going to go better than that, but like that. And that's one cycle. So now from one of my endpoints, I'm going to go 1, 2, 3, 4. I have a point at 0, 1, and negative 1. And there's another cycle. Other direction, I'm going to go from here, 1, 2, 3, 4. And I've graphed 3 cycles now.
Are we always supposed to graph 3?
Yeah, do 3. And if you only give me labels and points for the middle cycle, that's fine. You'll notice I didn't put numbers here. So make one of them really, really good, and make the other 2 pretty good. Okay, so is there a question about that? We'll do one more. I'm going to do 3 tangent theta. So now, this is my A value. Tangents don't have an amplitude, because they're not sines. They're not a sine wave. They're not sinusoidal. That's a funny word. But they can still get stretched. They can still be vertically stretched. What's the period of tangent?
180.
Good, so this is going to be 180 over 1, so it's still 180. Which means that from the middle, I'm going to go right 90 and left 90. Because that's the total distance of 180. Total distance there is 180. So this little guy is negative 45, and this little guy is 45. There's a 0. I'll go 1, 2, 3. Well, asymptotes are at 90. The tangent of 0 is still 0, and 0 times 3 is still 0. So this is going to be a 0 right here. But what's the tangent of 45? 1. So it's 3 times the tangent of 45.
3.
So where it used to be at 1, now it's at 3. These middle points are just going to be higher and lower. Compare how this is at 1 to how this is now at 3. Because my scales are kind of off, it doesn't look that different, but it will be. This one is stretched much more vertically. I can go boom, boom, boom. And there's another one. And boom, 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 boom. There's that one. That's tangent. Any questions about that at all? Great, you got a good chunk of time, you should get to work.